In this lecture, we're going to talk about electron spin. Now, electron spin means that each electron has a net magnetic dipole moment. We know that electrons have negative charge. What you're not probably familiar with is that an electron also has a magnetic field. So this magnetic dipole moment is called, these are different words that are used to describe this magnetic field. So when you think of an electron, think of a bar magnet having a north pole and a south pole. So it's an electron is going to look something similar to, it's going to behave something similar to a bar magnet. It's going to have a north pole and it will also have a south pole. So you're familiar with the fact that two electrons repel each other because they have negative charge. Now, what you need to familiarize yourself with is you have to think of an electron as a magnet having a north pole and a south pole. So think of two magnets, the two arrangements. Here you have a north pole and a south pole, and there's another bar magnet having a north pole and a south pole. Now, based on this configuration, since north pole and south pole are opposite poles, so there's going to be a net force of attraction between the two bar magnets. Similarly, based on, if you imagine this bar magnet as an electron having a north pole and a south pole, and this one also having a north pole and a south pole, since the north pole and south poles are pointing or attracting each other, the two electrons would attract each other. The magnetic fields would attract each other. So previously we've studied the two electrons repel each other because both of them have negative charge. Now that is an electric field of repulsion because this has a negative charge and this has a negative charge. So there's going to be an electrostatic force that would be repelling both electrons. But since now you know that an electron also has a magnetic field, it has a north pole and a south pole. This electron also has a north pole and a south pole. So based on this configuration, the two electrons can possibly attract each other and their magnetic fields would be attracting each other. So this term, when two electrons they attract each other, this is, in simple words, it's called that they are having opposite spins. And remember, this word spin basically refers to the magnetic field. So one has a north pole and the other one has a south pole, and they're pointing to each other. So they're going to attract each other. The magnetic fields would attract each other. Now there's another scenario with two electrons and the magnetic fields could also repel each other. So if you have this configuration where you have an electron's south pole, so think of an electron as a small tiny magnet having north and south poles. There's this another electron. Now in this case, the bar magnets are having the south poles pointing towards each other. So they're going to repel each other because same poles in a magnet, they repel each other. Opposite poles, north and south poles, they attract each other. So this time the two electrons, the magnetic fields are going to repel each other. So the word that we're going to use to describe this is that the two electrons have the same exact spin or magnetic dipole moment. So that is the word that is used to describe this magnetic field. So this is a new concept. Think of an electron as a magnet, as a tiny magnet having a north and a south pole. And two electrons can possibly attract each other if the magnetic fields are opposite. If one has a south pole, the other one has a north pole, they would attract each other. This phenomena is referred to as the two electrons having opposite spins. Similarly, the two electrons and the magnetic fields can repel each other if the magnetic fields are the same. If one has a south pole, the other one also has a south pole, then the magnetic fields would repel each other. So the word that we're going to describe the two electrons with is that they are having the same spin. So make sure this idea is clear that if two electrons have opposite spins or opposite magnetic fields, the two electrons can possibly attract each other. If they have the same spin, then the magnetic fields would repel each other and it would be very hard for the two electrons to be in the same place. Now, based on this idea that two electrons can possibly attract each other if they have opposite spins or opposite magnetic fields, we're going to talk about an orbital now. And previously, in the previous lectures, we discussed that orbitals are regions where electrons have a very high probability of existing. So there's a very high probability of finding an electron in different orbitals around the nucleus. Now, one statement is that each orbital or region around a nucleus can have a maximum of 2 electrons. So an orbital cannot have more than 2 electrons. A maximum amount of 2 electrons is possible. You can have 1 electron, you can have 0 electrons. It would be empty, but it cannot have more than 2 electrons. Now I've drawn an s and a p orbital just as an example. So there's an s and a p orbital given. Now if 2 electrons are occupying the same region, for example there are 2 electrons in an s orbital, so there are 2 electrons roaming around in this s orbital. Now as previously described, these electrons are traveling very fast, so no one has ever actually seen them stationary, so they're traveling very fast. So to an outside observer it appears that the 2 electrons are everywhere in this spherical s orbital. So to an outside observer it appears that the 2 electrons are everywhere. Now since both electrons are negatively charged, the 2 electrons would try to repel each other. So 1 electron would repel the other electron in opposite direction. So there's going to be an electrostatic field of repulsion. So there would be an electrostatic field of repulsion between the 2 electrons. And what this repulsion would do is that it would be very hard for the 2 electrons to exist in the same space. So both electrons would try to repel each other and they would try to knock each other out. Now we're going to bring in the concept that we just studied, and that is that it is a possibility that 2 electrons can attract each other if they have opposite spins. So if they have opposite magnetic dipoles, the magnetic fields might attract each other. So what happens is that the electric field of repulsion is cancelled out, and it is cancelled out because the 2 electrons will have a magnetic field that would attract each other. So the 2 electrons would try and attract each other because they have a magnetic field that is opposite. They have opposite spins. So this electrostatic field of repulsion gets cancelled out because the 2 electrons have opposing or opposite spins. So the magnetic field actually ends up attracting. So there is a force of repulsion between the 2 electrons, but the magnetic field sort of balances that out. The magnetic field of the 2 electrons would attract each other. So the magnetic field needs to be opposite. The spins need to be opposite. The only way the 2 electrons would attract each other is if they have opposite spins. If one has a north pole, the other one has a south pole, only then can they attract. If the 2 electrons have exactly the same spins, if one has a south pole, the other one also shows up with a south pole, the 2 electrons will never be able to cancel the electric field of repulsion. So revising this minor point, that point is whenever 2 electrons exist in an orbital, whether it's a p orbital or a d orbital or an f orbital, the 2 electrons can only exist in the same region if the magnetic fields are attracting, because the electric fields are already repelling them apart. So the electrostatic field of repulsion is already making it very hard for the 2 electrons to exist in the same region. So the only way that's possible is that if the magnetic field shows up and the magnetic fields ends up attracting the 2 electrons, so the force of repulsion is going to get cancelled out and the 2 electrons would be able to exist in the same region. So whether it's an s orbital or if 2 electrons are existing in this p orbital, the spins would always be opposite.